Hi, I'm Dr. Sharon Pratt from the School of Education. I'm an assistant professor of elementary and literacy education. So I'm looking forward to sharing some of my research on how elementary students read science texts that have many visuals and unique reading pathways, or multimodal nonlinear science texts. So first, I would like to acknowledge a few people who have contributed to this work, including Dr. Nita Benna here at IU Northwest and Dr. Julianne Coleman at the University of Alabama, as well as our student research assistants, Katrelia, Kristen, and Charity. So let's situate this study within the reading we do as adults every day. How often do you notice or see visuals throughout your day? Along the highway, maybe as you drive, on news websites, brochures at the doctor's office, etc., etc. Notice here on this slide 3 visuals that I read in the last week as I glanced over the Washington Post news page to read pandemic updates. These 3 visuals show the number of COVID cases, a comparison of deaths to those in the Vietnam War, and the rate of vaccine distribution. So visuals really are all around us and are increasing in the sources from which we draw information. So when you're reading a text with visuals, where do you start? Do you glance over the visuals and read the text and return to the visuals with more focus? Or do you start with the written text and maybe even skip the visuals? What strategies do you find yourself using to put together information from the written words with what you see in the visuals? So when we think about elementary students, they too are finding more and more visuals as they read texts in school and their everyday lives. The increase in visuals makes the reading process more complex, as they need to decode not only what the written words say, but what the visuals are portraying. So to demonstrate, here are 2 page spreads from 2 science nonfiction texts for elementary age students. The one on the left is a traditional reading pathway that is linear, meaning we read the pages from top to bottom and left to right. However, the text on the right does not present a traditional reading pathway. Rather, there are many blocks of words or text scattered around the page with captions and diagrams, as well as numbered steps of a process that go diagonally from the middle left to the top right. So this text presents the reader with options of where to start and what order to read the visuals and the written words. And though text students are reading in elementary school are increasingly nonlinear and include more visuals, there is little research exploring the strategies elementary students report using to read science texts that include lots of visuals. So our study focused on whether there were relations between the strategies 4th grade students self-reported for reading a multimodal nonlinear science text with their comprehension of that text. And we included 76 students from a local urban school who are in 4th grade. We randomly assigned students to read either this life science text on jet propulsion of sea animals or this physical science text on robotics with the building of animatronics. And after students read the text, we asked them several questions about what they read on the pages, in what order they read those parts, and what strategies they used to read the information. We then gave them a multiple choice reading comprehension test that included questions about information in both the written words and the visuals. We used their average score on the comprehension test of 50% correct to divide the group into more and less proficient readers. And we then compared these 2 groups using epistemic network analysis to find patterns that emerged in our coding of their interview responses. So epistemic network analysis, or ENA, allows us to see patterns within the data, which in our data were reported strategies students use to navigate and read these multimodal science texts. We can also compare different groups to see if there are differences that are statistically significant by seeing where the means of the groups fall in the graph. So in our data, the 2 groups of more and less capable readers did show differences in their self-reported strategies that were statistically significant. So here's an ENA graph for the students who had more difficulty comprehending the text or were the less capable readers. Their mean is a red box slightly to the right in the middle of the graph, meaning these students reported codes that were more on the right side of the graph. And we can see several predominant patterns of reported strategies, including the dark red line in the middle of the graph between the codes SVIS and IN, showing these students chose to read some of the visuals based upon what interested them, the IN code. The code D is also present on this graph, showing they relied more on a basic reading strategy of decoding by figuring out just how to say the written words. And they also used more traditional reading pathways of top to bottom and left to right, as evidenced by the T code towards the bottom of the graph, going diagonally then to the right, the PH code of physically tracking their text, and the P code of pointing to the text while they read. But conversely, notice the ENA graph for the more capable readers showed they are more likely to read all parts of the text, the large A code on the left side of the graph, as they use comprehension strategies, the C code up at the top left. And they tend to preview a text to determine a reading pathway, or what order they're going to read the text. And these more capable readers also reported integrating the visuals with the written words, or the INT code. And notice the EVIS and the EVER codes more on the left, which represent these students being better able to explain how they use the visuals and the written words to better comprehend the information within that text. So thus, we see the students who were better at comprehending the text went beyond the basic reading strategies seen in the less capable readers to those that were more specific for reading nonlinear text and visuals. So this study informs us that we need to support elementary readers in learning more complex strategies for reading these more complex texts, especially as texts are becoming more visual in school and our everyday lives. So our next step in research is to explore effective methods for teaching students strategies to improve their comprehension of more complex science texts.